Okay. All right, so if you don't have a notebook, I would recommend grabbing one. Hopefully you do. We are going to go over your notes, but I actually think the PowerPoint might be nicer for you guys. It might be bigger. Okay. Can you still see that? Even though I didn't like do the individual screen share? Cool, great. All right, so little side note, for some reason, Cengage doesn't have section 1.1, so I did my best to give them all the credit because I needed you guys to have it, but they decided not to give it to me. So Cengage didn't really make this, but I used all their products, so it is what it is. All right, so statistics. Somebody tell me about it. What do you think it is? Yes, I'll let you know that this is going to be a discussion-based class. I know, it's weird. You think math and I won't have to speak and I can just sit here and take notes and look pretty. But I teach very differently. My methods are very odd. So we will do a lot of what's called exploratory learning. It actually works better for you. You learn more. So you had to have at least heard of the word statistics before you signed up for the class.
When I think of stats, I think of like numbers, but like you said, it's more than just numbers.
Mm-hmm. So when we are thinking about stats, we don't, well, I know at least one of you because I just saw the background with the basketball and the football and the everything. So stats are largely going to be found where?
In sports.
Yes. Okay. So not to coin a phrase that is used all the time and students like to eye roll, but math is literally found everywhere. Statistics is probably one of the biggest proponents to why math is found everywhere. Without stats, you can't really, even though stats will be confusing, there will be points in this class where you will go, I have no idea what you're talking about. I need you to break it down for me in a different way, which might be how you feel about most math classes. I don't really know. But statistics is going to be how a person who, let's say, only sees life in numbers can have a conversation with someone who doesn't see numbers at all. It's a way to present the world mathematically with words. Okay. And if you really want a true definition, we will get to it soon enough. These are our focus points for chapter 1. It's not just, I don't believe it's just for section 1.1. Maybe it is. Who knows? You don't have to worry about writing these down. I'm not going to quiz you on them, but I'm also not going to insult your intelligence. You can read them. So variables, when you hear variables in this class, unfortunately, you can't just think X, Y, and Z. Kind of have to go and dig a little bit deeper. So if you were to take a guess as to what kind of variables someone might be interested in, what do you think one of those variables could be?
You could think about like economists, interviews of like the stock market and such. They're taking statistics through that and extrapolating which venture capital is worth investing in. So the variables there would be expected profits or lack thereof.
Okay, so you're taking in quite a few things, right? So you also need to kind of consider the risk and reward factors there. You know, how much money are you willing to part with in order for what kind of gain? You know, it's a very math heavy example, so nice job there. Uh, but you know, we can also think about variables as just male and female, people that are taller than 5 foot and people that are shorter than 5 foot. Variables are basically our desired, what we want to know about. Okay, so right now with um, the coronavirus, we want to know what's going to save everyone. Okay, obviously we know from um, what was that, like 13 months ago, that bleach was probably not the answer. Okay, so we want to think about those kind of things when we're talking about studies. We want to distinguish between quantitative and qualitative. What would that difference be? Those of you that would like to fall back on your um, English factors there, that would probably help you. That's the word I wanted, English. It's so hard for me.
The qualitative is measured of like based on the quality of something, and the quantitative is measured based on numbers.
Yes, very close. So when you say quality, it's more like how you describe something. So if I was talking about chips, not the kind you eat, but the kind you play with, then, you know, I could describe them as green, blue, purple. I don't know how much money purple would be. But so that descriptor is qualitative, whereas the numerical side of it would be quantitative. Exactly. Good. Okay. We're going to identify populations and samples. Why would that be something we would want to know? Do they have a difference there? Is it the same thing?
Well, with populations, if it's a much larger population, it's usually realistic to take a sample of it, especially if you think of like a census or something in a country. If you're trying to determine what have you, a behavior or a lifestyle of somebody in the country, and you want to take a poll of that, if you want to take a rough estimate of it, you take a sample size, and there's so many different ways you could take those samples, but it's supposed to represent a larger population.
There you go. Yes. So, and another thing you want to think about is that in terms of our formulas, which we do get some formulas, and early on you'll have more formulas than later, there are differences between those representations. So you're really going to want to basically have some note cards or some charts that you can look at where you'll have population and you'll have sample. Okay, so those are going to be two key things that are going to be different for us. We're going to distinguish between parameters and statistics. We're definitely going to talk about level of measurement, and we're going to compare descriptive versus inferential statistics. I should let you guys know up front that I am not only slightly dyslexic when it comes to overall things, but I will have to reference a lot because for me, and maybe it makes me a good teacher, maybe it doesn't, but there will be times you might ask me a question. I'll go, wait a minute, we have to write this out because I just can't see it in my head. So, all right, that was a long introduction. So statistics helps us make decisions. Whether you know it or not, you do end up doing some kinds of statistics just kind of off the cuff, on your own every day. If your car breaks down and you need to buy a new car, you're not just going to go out and buy the fanciest or nicest car that you want, right? Because I, myself included, we are not financially able to do that. Okay. If you are, good for you. Don't tell me about it. I'll be a little bit sad. So we have to take certain things into account. Money, um, you know, money is going to probably be a large example that we use. We have to know how much money we make so that we can know how much money we're going to be able to, save up for a down payment. We have to know how much money that we're going to be able to afford for a monthly payment. Granted, those are probably examples better for my financial business class, but I mean, it still holds true here. If you don't understand some kind of basic level of statistics in your life, then you're not really going to understand how to do certain things. Okay. You can see you can see statistics in nature pretty much wherever you look. We're going to go with the definitions for statistics in this situation. The top one is most correct, kind of the more boring one, I feel. There's a reason why I have Professor David Hand up here, and that is because if I do throw a bonus question at you, this is going to be the answer. Okay, throwing it out there. Not sure if I'll use it, but I really like the way he gives this different kind of situation. So he says statistics is both the science of uncertainty and the technology of extracting information from data. I just think that's a perfect way of describing it. The one up top, it's nice, but it's also been around for like 150 years. It's kind of boring. Okay. Unfortunately, stats is going to have a lot of vocab. So it's up to you guys, but after today, I'm going to assume that you're either going to go with the ebook or get a physical book. If you read the chapter ahead and take out the key information, you'll probably have less of a hand cramp during the live Zoom and be able to participate and or ask questions more. Okay. I'll also need some kind of thumbs up to let me know when it's good to go. Okay. All right. Should you need more time, I always put the YouTube video up the same day. And if I don't have it up, then please shoot me an email, but I really should have no excuse this semester. I only have one class a day. Okay. So, here's the thing. Individuals are the people of objects included in the study. I like the term participants. If you're talking about humans, I don't know why. I just feel like it's, I don't know, nicer, part of a whole. I don't know. Individuals, whatever. It's what the textbook people wanted. Okay. A variable is a characteristic of that individual or participant or object that is being measured or observed. I don't know. I'm not going to sit here and make up examples for you because we're probably going to have to answer those kind of questions down the road. So, you can see that I really have an issue with it because I put it really big there. Okay. All right. Quantitative and qualitative. We all discussed that before. Which, again, if you guys don't feel like you need to write something down, yeah, you You're kind of adults to me at this point. So yeah, you're adults. Do what you want. You don't want to take the note down, don't take it down. All right. I do recommend going back through when you study for your exam, going back through our live notes and making sure that if you miss something that you write that down. All right. So sometimes qualitative variables are referred to as categorical variables. That's just kind of a nice way for them to give you a hint as to what it is. You know, if you can place it into a category, a word category, not a numerical like 1 through 10 category, then it's qualitative. All right, population data and sample data you can see there. Biggest difference is that data from a specific population are fixed, whereas data from a sample can vary because it's not complete. Okay. Oh, no. Well, that one breaks off a little bit. There you go. So a population parameter is a numerical measure that describes an aspect of the population, kind of basically gives you its definition and its name. Sample statistic describes an aspect of the sample. Okay. So I kind of tried to give you some examples there. If we have data from all the people who have climbed Mount Everest, then we have a population data. Okay. Vice versa, if you have only some information, then you have a sample. And I promise it does get a little bit more fun after the vocab chapters. Okay, so let's try to put some of this into practice. We have this scenario where we want to know how important music education is for K through 12. Clearly, it would be important if you were wanting it to be your career, which is, I guess, why they don't ask if it's important in college. All right. So the Harris poll did an online survey of 2,286 adults that were 18 and older within the US. Among the many questions the survey asked, if the respondents agreed or disagreed with the statement. Okay. In the most recent surveys, 71% of the study participants agreed with the statement. Okay, so if you identify the individuals of the study and the variable, what would that be? What do you think?
Adults that are 18 and older.
Okay, so adults that are 18 and older would be part of it, but you more specifically want to give the number of the adults. So the 2,286 adults, that's kind of more what they're looking for in terms of who was involved. The variable, what do you think the variable is for this study?
Whether or not they agreed or disagreed.
Excellent. Perfect. Okay. So do the data comprise a sample? If so, what would be the underlying population? So think about it. And David, you kind of looked ahead when you were answering A. So think about that when you go to answer B.
I think it's a sample. The underlying population would be whether or not they're 18 or older.
So close. We have adults that are 18 or older. So that is kind of glaringly telling you have a sample. So what's that larger population going to be? Where are we getting those 18 plus year olds?
You'd look at the entire adult population of the United States.
Yes. Very good. Okay. Is the variable qualitative or quantitative? So think back to what Tucker said. He said that the variable is if they agree or disagree. So would you consider that qualitative or quantitative?
Quantitative?
So if we're dealing with quantitative, we're dealing with something we can count. I mean, this is a little bit tricky because if I wanted to make it a quantitative question, I could. But I want you guys to think about how you could make it a quantitative question. What does quantitative deal with? It deals with what?
Wouldn't it be like counting the amount of people who agree and the amount of people who disagree?
Okay, so that is where you're talking about the actual statistics between how many people, if we gathered this data from 2,286 adults in the US, now you could say, what's the probability that you would get someone who agrees? That's where those numbers are going to come in and help us. But the actual terms agree and disagree, those are qualitative terms because the only way you can turn them into quantitative is if we said in the study, if a respondent agreed, they put a 1. And if they disagreed, they put a 0. So that's how you change it. Okay. If you just see words, though, you want to just go with qualitative. Make sense? Good. Okay. So D there says identify a quantitative variable that might be of interest. That one we can look at in the next slide because I don't know why they are even including it. And then the last one is the proportion of respondents in the sample who agree with the statement. Okay, so let's take a look at the answers. This is an interesting one. I guess it's trying to get you guys to dive deeper into the study. I just feel like chapter 1's a little bit early for that, but hey, whatever. And then the last answer there is the statistic or the proportion is computed from the sample data. Okay. All right. Most of those you should probably have gotten while I was talking. All right. This one I'm going to give you a few minutes to write down if you feel you need it. If you have any questions with it, you can go ahead and ask me, but I'm going to let you know that you will probably just have to do questions over and over and over again to really get a handle on level of measurement. Okay. So nominal level of measurement, it applies to the data that consists of names, labels, or categories. The ordinal level of measurement applies to data that can be arranged in order. Interval applies to data that can be arranged in order in addition to there are differences and those differences have meaning. And then ratio. The next page or the next slide kind of does a little bit nicer of a job to help you guys out in terms of like setting it up. It's what I would pay more attention to. Okay. All right. Any questions on level of measurement? I will not be shocked if you have some. It's not the most easiest concept. Okay, so I'm gonna try to get us started into section 2. We still have a few more slides in this, but it's just another example. Yes. Okay, so if you read over this really quickly, we're just going to kind of try to do an application of the level of measurement. So the level of measurement tells us which arithmetic processes are appropriate for the data. This is important because different statistical processes require various kinds of arithmetic. In some instances, all we need to do is count the number of data that meet the specified criteria. In such cases, nominal and higher data levels are appropriate. In other cases, we need to order the data so that the nominal data would not be suitable. Okay, so we're just gonna look at some examples here. Okay, so the senator's name is Sam Wilson. How would you categorize that?
Nominal.
Yes. Okay. The senator is 58 years old. So what I'm going to do to save time is we're going to look at them and I'll give you a few seconds to kind of look at them and get your thoughts behind them and jot down what you think the answers are. And then I'll go ahead and switch to the answers. And if you end up watching this again, you can always pause. But I'm sure I give you enough time in class to look at it that you will probably never have to pause. All right. Okay. So, yes, nominal is correct. The second one is actually ratio. Notice that the age has a meaningful 0. Makes sense to give the age a ratio. For instance, Sam is twice as old as someone who is 29. The years in which the senator was elected were 2000, 2006, and 2012. You want to go with interval. Dates can be ordered and the different dates have meaning. For instance, 2006 is 6 years later than 2000. However, ratios do not make sense. The year 2000 is not twice as large as the year 1000. In addition, the year 0 does not mean no time. Okay. The taxable income for the last year. Man, maybe I need to just quit what I'm doing and become a senator. That's a lot of money. Although I think I would A, not be voted for, and B, I don't think that's enough money for the headache involved. Okay. For the next one, the senator surveyed his constituents regarding his proposed water protection bill. The choices were strong support, neutral, against, or strongly against. I'm sure they also got a lot of write-ins. So you're going to go with ordinal. The choices can be ordered, but there is no meaningful numerical difference between two choices. Okay, apparently we care if the senator is married. It's going to be nominal. And a leading news magazine claims that the senator is ranked 7th for his voting record on bills regarding public education. Again, that is ordinal. Ranks can be ordered, but differences among the ranks are meaningless or may vary. All right, any questions on level of measurements? Here's another 2 vocab. Don't lose sight of those just because it's the last slide. We will look at methods of descriptive statistics in chapters 2, 3, and 9. They are going to be where this particular set of vocab will be seen again. Okay. All right. Questions from 1.1. I do suggest after class, if you have time, that you go ahead and do the homework in WebAssign. If you have issues getting into WebAssign, I do have time until 5 o'clock today to answer questions. All right. When you're done, I'm going to switch us to section 1.2. And then at 2 o'clock, typically I will probably let you leave at 2 o'clock unless we're like involved with something. Don't know why that's there because that is a blank side. But at 2 o'clock, I do want to let you know about some other things that I forgot on the syllabus. Oops. All right. Everybody good with 1.1? Cool. Okay. All right. Let's get out of that. And I will shut that down. And 1.2. Okay. Okay, so don't be confused. They have the same starting slide every time. It only gets mildly annoying when you think you've pulled up the wrong one. Okay, so section 1.2 is random samples. We want to look at explaining the importance of random samples, constructing a simple random sample using random numbers, simulate a random process, and describe stratified sampling, cluster sampling, systematic sampling, multi-stage, and convenience. I do apologize. I wish we were doing more mathy type stuff, but unfortunately, it's just talking today. Hopefully it won't be talking for too long. Okay, so we are going to use a lot of sampling techniques in this section. One of the most important sampling techniques is a simple random sample. What is a simple random sample? Well, that's when there are a certain number of measurements from a population and the subset of that population selected in such a manner that every sample of size n from the population has an equal chance of being selected. Okay, great. I can read. What does it mean? read back over the definition to yourselves and try to think of what the first thing is that would come to your mind as an example.
If you were surveying people and you survey people just off the street in a random city,
Mhm.
not with no predisposition to who you're selecting.
Okay. What are you? So I will agree that that is a random sample. I'm not sure if I would consider it a simple random sample because we want to make sure that everyone available would have the same chance of being selected. So if you were just walking around on the streets of a major city, you're probably going to come across more homeless people during the middle of the day than you would people that are at their jobs working, right? So I think I was trying to go for a little bit easier of an example there. What do you guys think? And Tucker, I'll give you that is a random sample. It might even be a simple one if you gave yourself the right parameters. Man, I wish I wasn't so poor. Okay. Oh, I'm also very small right now. So if I show you this in my camera, then you won't be able to see it. What is that? I wish I could show you something more expensive. And also, this one's a lot harder to flip. But it's a coin. So if a coin is fair, that means it will have what?
Two sides.
Well, it does have two sides, but a fair coin will also have the same probability of landing heads or tails no matter how many times we flip it. So if we flip a coin 1,000 times, 500 times should be heads and 500 times should be tails. So that is a good example, or I guess a different example of a simple random sample. Another one could be what? How many people like to play games? Okay. Games can sometimes involve what?
Dice.
Dice. Okay. If you have a fair die, depending upon how dorky we all are, you can either have the possibility of 20 sides, or you could have the possibility of 6 sides. Okay. Obviously, the probabilities change depending upon the number of sides you have, but they should all be somewhat equal. Although, if you're trying to roll a critical save, you might not always feel that. Okay. All right. So, simple random samples. All right. Not only does every sample of a specified size have an equal chance of being selected, but every individual of the population also has an equal chance of being selected. However, the fact that each individual has an equal chance of being selected does not necessarily imply that there is a simple random sample. Remember, for a simple random sample, every sample of the given size must also have an equal chance of being selected. Okay? A lot of words of just saying that. Make sure that you're really paying attention to what's going on. Okay. All right. Random number table. Use a number table to pick a random sample of 30 cars from a population of 500 cars. All right. Obviously, it's a little bit difficult to do this on the computer, so I just went ahead and left the solution there for you. They're going to assign the numbers between 1 and 500. All right. So then when they use the table, then they have a corresponding car. Okay. I don't know why you would choose to do this. I can't really tell you that it's something that we'll do after these sets of questions, but it's just the example they're giving. Again, remember, you don't have to write down everything. Okay, so when you read the digits by beginning anywhere in the table, we dropped a pin on the table and the head of the pin landed in row 15, block 5. We'll begin there and list the digits in that row. If we need more digits, we'll move on to the 16th row and so on. So these are the digits where we begin. All right. Again, some of it might be confusing. Some of it might just look like gibberish, but basically they went to a very large table and they pulled some numbers. Okay. If you look at this case, they're going to pull some numbers out and they're going to exclude other numbers because we know that their numbers are 1 through 500, right? So you obviously can't have car 992 if your stopping point is 500. Okay. And again, this example, you don't have to write it down. It's just something we can talk about. Helps with the time. All right. As are kind of most examples in life, but most of them tend to have a little bit more meaning than this one. Okay, so the next set of 3 digits is 15, which corresponds to car 15. Right, car number 15 is the first car included in our sample, and then 221 and so on. Okay, there you go. I think if you wanted to really dive into that problem, I guess you could randomly Google 500 different kinds of cars, write them all down, and then you could randomly select however many you wanted to. I don't recommend spending your time doing that. I don't think you're going to get a lot out of it. But hey, if it's something you really want to do, I recommend just doing your homework. I'm sure they'll ask you a similar question. All right. So this tells you how to draw a random sample. Number all members of the population sequentially. So if we were going to do something, say at LTRI-C, then we would have all students that are on campus on Monday. Everyone would be given a number. It would start at 1 and end at wherever we're at. Okay. Use a table calculator or computer to select random numbers from the numbers assigned to the population members, and then create the sample using the population members with the correct corresponding to those randomly selected. Why would most people take part in this? They probably wouldn't know to say no. I'm sure if someone walked up to you and said your number is 12, you would go, okay, but I really like 33. It's not like you're going to mess up their survey. All right. Another important use of random number tables is simulation. Okay. We use the word simulation to refer to the process of anything relating to real phenomena. Simulation methods have been productive in studying a array of, you can read all that for yourself. Okay. Questions to this point? What number am I on? 12? Let's see. Can we get through the whole thing? I don't know. Maybe. We'll see. I don't think so. I think this one's really stupid long. Okay. All right. We'll at least try to get halfway, and then that'll be a section and a half for each class. All right. A complete list would probably include something from every aspect of modern day life. A simulation is a numerical whatever that word is, face and a smile, I don't know why they're together, or a representation of a real world phenomenon. Okay, words. We have to deal with them. It's obviously not a mathy word. I don't like it. Okay. This page we can skip. All right. Other sampling techniques. Let's see. Stratified sampling and group or classes are often called strata. Again, this is probably just going to be easier for you guys if you read through the textbook and pull out what's important. I'll give you a hint. If they kind of mention it in the PowerPoint, then the corresponding information in the textbook would also behoove you to know about. Okay. All right. That is halfway. So before you disembark,